Alright, today we're going to go over Algebra 2P for this Algebra 2B 3.2 Part 1, which is page 176, 1, 2 to 42 even. You're going to need to know these properties. So, the first property I always talk about matching bases. If the bases match and they're next to each other, you add the exponents. That can also work backwards, and the book does that a lot, where they take a bigger exponent, maybe it's a mixed number, and they split it into two bases with different exponent, the same bases with different exponent. If the bases match and they're on top of each other, then you're going to subtract the exponents. If you have an exponent to an exponent, you multiply the exponents. If you have two things to one exponent, remember that exponent's got to go to both, like the distributive property for exponents. That works if it's a fraction as well, where it goes to the top and bottom of a fraction. Remember, you're not allowed to have a negative exponent, so you have to put one over the, you have to put the, like it's like we talk about if you have a negative exponent, like you didn't pay your rent, so you got evicted, he was on the top, now he goes on the bottom. Or if it's a negative on the bottom, it can go up to the top. The other thing that's big in this section is you want to be able to change the radical from exponent form to radical form, and that works both ways. So you could take a radical and turn it into an exponent, and vice versa. Sometimes it's easier to do radical stuff, like when you want to simplify, and other times it's easier to do exponents because there's a lot more properties to use. Now here are the radical properties. You have the nth root of a times the nth root of b. That's if you have multiplying the same radicals, then you put them together, or you same thing with division. Remember, you have to simplify so you have to have no perfect factors inside the radical, and you have to have no radicals in the bottom. Alright, and there's the perfect numbers that we'll be using. There's probably way more than that, so that's just a quick little list. Alright, are 2 radical 5 and 2 cube roots of 5 like radicals? No. They are not exactly the same. They have different index. Remember, this one right here actually has an index of 2. This one has an index of 3, so they are not like radicals. Under what conditions is a radical in simplest form? So remember, the first thing is there is no perfect factors inside the radical. So that, and all depends on, that's based on the index. So that's based on the index. So there's no perfect cubes if it's a cube root, no perfect fourth powers if it's a fourth root. And the next thing is you cannot have no radical in the bottom of a fraction. And that's it for 2. Number 4, we have 6 to the 2/3, all to the 1/2. That's an exponent to an exponent, so you're going to multiply them. So this is the property. So you have to multiply 2/3 times 1/2, so it's going to be 6 2/3 times 1/2. You multiply across the top and across the bottom, you end up with 2 6, which is going to turn into 1/3. So I have 6 to the 1/3, and that's it for 4. All right, number 6. Remember, these are matching bases. They both have 9s as the base, and even though you don't see that exponent, there's actually a 1 as the exponent. So we're going to be using this property that says if your bases match, you subtract the exponents. And even though it's a negative exponent, I'm still going to subtract it. So I'm going to write it as 9, 1 minus negative 4/5. I'm going to do 1 minus, so that's like adding 1 and 4/5. Remember, you do not want to mix a number. So that cannot be mixed. So there's 2 ways to do it. You can just make it an improper fraction, 9 and 9/5. That's going to be the easiest way. Or you can split this, where this is going to be, because that's like basically 1 plus 4/5, so it's going to be 9 to the 1st times 9 to the 4/5. So either one. And that's it for number 6. There's a bunch of ways to do number 8. What I'm going to do first, because that's what it seems most people in class did, is this. So they took the radical to the top and the bottom. I end up with 7 to the negative 1st over 4 to the negative 1st. Now, since the radical, or since the exponents are negative, they're going to go to the opposite side of the fraction. So 7 is going to go to the bottom, 4 is going to go to the top. I end up with 4 over 7. That's not right. 4 over 7. And there we go for number 8. Alright, so number 10 we have 12 to the 3/5 times 8 to the 3/5 all to the 5th power. There's a bunch of different ways to do it. What I like to do is I like to just, I notice that those exponents match, so I kind of factor out the common exponent. So I'm going to take these 3/5, I'm going to put them both outside, so they're going to turn to 1. So I'm going to have 12 times 8, all to the 3/5 times 5. So I took the two matching 3/5, they turn into this one 3/5 right here. 3/5 times 5 is 3, so I end up with 12 times 8, which is 96, all to the 3rd power. You can do this as 96 to the 3rd power, or you can write it as 884,736. And that's it for 10. Alright, number 12 is going to be accuracy. Biggest issue with reason this is accuracy is so many people weren't paying attention when I went over the fire starter yesterday. So that's an accuracy problem. If you paid attention during the fire starter, you have it. If not, I'd recommend looking for matching bases and then using this idea or using this idea to make matching bases. That's it for 12. Alright, 14 we have 13 to the 3/7 over 13 to the 5/7. The bases match, so I make this 13 to the 3/7 minus 5/7, which is going to be equal to 13 to the negative 2/7. Now remember, you cannot have a negative exponent, so we're using this property. It says if your exponent is negative, I'm going to move it downstairs to the bottom of a fraction. So I have 1 over 13 to the 2/7. Now the next part here is that it gets really tough, is I have to remember that I'm going to be using this property right here, because I'm kind of done with exponents. But what I have to remember is that a fraction exponent is just a fancy way to say I have a radical. So I actually have 1 over the 7th root of 13 squared. So I actually have a radical on the bottom. So this problem's not done yet. So I'm going to multiply. Remember, you have to multiply by 1. So I'm going to multiply by the 7th root of 13 to the 5th. Well, why did I pick 13 to the 5th? Because, and that's not 135, so if I just didn't, I'll do a better job writing that. Why did I pick 13 to the 5th? Because I have two 13s here. I have 5 more there. That will give me a total of the 7th root of 13 to the 7th. That's what I want, because then those will cancel and my radical will go away on the bottom. Now the rule is if you do it on bottom, you have to do it on top. So I don't care what's going on the top. I don't care there's a 1 there. I just match. I take whatever I have on the bottom and I write it again on the top. Because now look, this is just a fancy way to say 1. No matter how ugly it is, it's the 1. Alright? So this becomes on top the 7th root of 13 to the 5th, all over the 7th root of 13 to the 7th, where the 7's cancel. So your best answer is going to be the 7th root of 13 to the 5th, which I'm okay if you leave it like that, all over 13. Or you can actually do 13 to the 5th out, and you're going to end up with 371,293. So it's the 7th root of 371,293. I think it's kind of big, so I would have left it probably as this one, but both of them are good. And that's it for 14. Alright, so 16 is pretty easy, but the cube root of 16 is not perfect. The cube root of 4 is not perfect, but if I put them together, I have the cube root of 64, which is a perfect number. So it's the cube root of 4 cubed. The 3's cancel, so my final answer is just 4. And that's it for 16. Alright, so number 18 is kind of hard because the way it is I have radicals, and I can't put these radicals together because the indexes don't match. These indices don't match. So I have to figure something out. The only thing I can really do is I can tell you, if you use this property right here, you can put your radical and you can put it in exponent form. That's going to help us out because you can do a lot more stuff with exponent form. So this can become 3 to the 1/3, because m is 1, times 3 to the 1/4, all to the 12th power. Now, as those bases matches, I get to do 1/3 to the 1/3 plus 1/4. Remember, the whole thing's to the 12th power still. 1/3 plus 1/4. I'm going to make 1/3 4/12 and 1/4 3/12. So I end up with 3 to the 7/12, all to the 12th power. Now I'm going to simplify that, and I end up with 3 to the 7th power. And that's going to be, so you can leave it as 3 to the 7th, or you can write it as 2,187, whichever you want to do. And that's it for 18. Alright, number 20. There's a bunch of different ways to do this. I think the easiest way to do this is to make it one big square root of 3 over 75, because I can simplify 3 over 75 into the square root of 1 over 25. I just divided the top and bottom by 3. Now I'm going to go back and take my radical to the top and the bottom. They're both perfect squares, so my final answer is 1/5. That is just one of a bunch of different ways to do this. That's just the one I thought the easiest. Alright, 22. That's going to be another accuracy problem. Once again, I did that as a fire start, and a bunch of people weren't listening. So, if you don't have that one, shame on you. So, accuracy. My recommendation for this is I would use this formula to put in exponent form after I combine the top and the bottom, because they have matching indexes. So that's it for 22. Alright, the square root of 72, I'm going to break that down into 36 and 2. The reason I'm using perfect squares, so I'm using 6 squared is 36, because it's a square root. Because remember, if you don't see that little index there, it's automatically a 2. So 36 is perfect. He gets to leave jail as 6. Remember, if you want to leave jail, you got to change. If he doesn't change, he goes right back to jail. 2 has to stay in jail forever, so it's 6 square roots of 2. And that's your final answer. Alright, there's a couple different ways to do this one, but the first thing I'm going to do is I'm going to say, since the indexes are the same, I'm going to do 4 times 108. I'm going to have the cube root of 432. Now I can break that down to 216 and 2. Remember, I'm using my perfect cubes, so if you're not sure, because of this index, I'm using this list right here. I'm using that list right there. Remember, 216 is perfect, so he changes into 6, because 6 cubed is 216. I have the cube root of 2, so it's 6 cubed root of 2. That's it for 26. Alright, so 28, I have the cube root of 16. Remember, I'm going to take the cube root to the top and the cube root to the bottom. The top works out nicely because that's perfect, because 1 is always perfect, so it's just 1 over the cube root of 6. Now, there's a couple different ways to do this. You could go through this list right here, and you could find out what number goes into 6, alright? Or you could just use 6 squared, because you need two more sixes to get 6 squared. So I remember that's 6 to the first. If I was a 3, it'd be awesome. So I'm going to multiply. So I'm multiplying, and the bottom I'm going to put the cube root of 6 squared, because this and this is going to give me the cube root of 6 cubed, which is what I want. Now remember, whatever's on here, I have to match on top, so this whole thing can equal 1. That has to equal 1. Because I can multiply anything by 1 and not change it. So I end up with the cube root of 6 squared, which is 36, all over the cube root of 6 cubed. Those 3's cancel, so I'm going to end up with the cube root of 36 all over 6. And that's my final answer. So for some reason, I think I did not hit record when I did this, so if you happen to hear this problem twice, I apologize. If not, then I was right, and I actually didn't record it. Now, I have the 6 root of 81 over the 6 root of 4, because the original problem is the 6 root of 81 over 4. So I take the radical to the top and the bottom, and I end up with this. Now I'm going to use some ideas here. I'm going to use this. I'm going to say 3 to the 4th is 81. I'm going to say 2 squared is 4, and I'm going to rewrite it. Now this is not the only way to do this, but this is going to be the way to simplify the radical and actually make the radical smaller, which is kind of hard to do most ways. Now I'm going to use this idea where I'm going to say if I have exponents, I can change them into radicals, and actually vice versa. If I have a radical, I can change it into exponent. So I'm going to do that. I have an m, I have an n, and then I have my a is the 3. So I'm going to make it 3 to the 4 6. I have an m, which is 2, I have an n, which is 6, and there's my a, so it's going to be over 2 to the 2 6. Now I can simplify both the fractions on the top and the bottom. So it's going to be 3 to the 2/3 over 2 to the 2/3, or 1/3. Now the reason I do this is I need these bottoms right here, these bottom for the fractions to match, because now when I turn it back, I'm going to use this again, and I'm going to turn it back into a radical. So I'm going to make this the cube root of 3 squared all over the cube root of 2. So now I'm just going to multiply by the cube root of 2 squared, because that will give me 3 2's on the bottom, which will make my radical go away, and I do that on the top. So 3 squared is 9, 2 squared is 4, so the top becomes the cube root of 36. And then 2, I have the cube root of 2 cubed. I do this on purpose, so then the radicals disappear on the bottom. So I end up with the cube root of 36 all over 2. And that's your final answer. Alright, number 32, I have 2 6 roots of 3 plus 7 6 roots of 3. Since the radicals are exactly the same, I get to add 2 plus 7. I end up with 9 6 roots of 3. And that's it for 32. Alright, 34, exact same concept. Radicals are exactly the same. So I do 25 minus 15 to get 10 5th roots of 2. Done. That's it for 34. Alright, 36. These radicals are not exactly the same. So I have to hope that they're going to turn into what so I'm going to use this list over here. I'm going to use this list right here. And I'm going to look for a number that goes into 625. And I find out that 125 goes into 625 5 times. So 125 is perfect. It leaves the jail as 5 because it's 5 cubed. So I'm going to have 6 cube roots of 5 plus 4 times 5 cube roots of 5. So this 125 turned into that 5. 6 cube roots of 5 plus 20 cube roots of 5. I end up with 26 cube roots of 5. And that's it for 36. Alright, so my radicals are not the same. So I have to hope I can break this down. And I find out I'm using this list over here. And I find out that the 4 to the 4th is 256. So I'm going to put 256 right here because it goes into 512 2 times. So remember, 256 is perfect, so he changes into 4. Minus 7 times 4 is minus 28. 4th roots of 2. 12 4th roots of 2 stays there. 12 minus 18 is negative 16 4th roots of 2. And that's your final answer for 38. Alright, so 40, once again, I have not the same radical, but this time both of them can be simplified. So I look at 48 and I say 8 times 6. Now, why do I care about 8? Remember, I'm using this list right here, so I care about 8 because it's a perfect cube. I don't care about 6. And for the other one, I care about 125. Because 125 times 6 is 750. Now 8 is perfect, so he's going to leave the jail and turn it into 2. So I have 5 times 2, so this 8 turned into that 2. Minus, remember, 125 turns into 5 cube roots of 6. 5 times 2 is 10, so I have 10 cube roots of 6 minus 5 cube roots of 6. I end up with 5 cube roots of 6 as my final answer. And that's it for 40. Now, 42 uses letters. And the only difference between letters and radicals is that you just have to get something. You have to get the letter to the matching power of the index. So this index is 3, so I have to get the bottom y squared into y cubed, because I'm going to do this. I'm going to take the cube root of x all over the cube root of y squared. Now, I don't care that the cube root of x is on top. That's fine. But the reason this one's not done is because I have this on the bottom. I'm not going to have a radical on the bottom. So I want the cube root of 1 more y. Why 1 more y? Because if I have 2 y's and 1 y, it's going to give me 3. I'll do the same thing to the top, because now this thing equals 1. So I multiply across the top. I have the cube root of xy all over the cube root of y cubed. Those little 3's cancel, so I end up with the cube root of xy all over y. And that's your final answer. Now what you notice is they on the book, they did not multiply the cube root of y to the top and the bottom. And that's why the answer is wrong. That finishes this problem. So accuracy for this is going to be 22, 12, and 22. So accuracy is 12 and 22. So check your fire starters. That's probably the easiest way to figure those ones out.